things. General angles and radian measure. Today I'm thinking we probably won't get into too much in terms of what are called radians. As rad as they are, we'll probably work primarily with degrees still. It's the radian, yeah. I got it. So all of our angles that we talk about are going to be based on the XY coordinate system. All right, the two-dimensional Cartesian plane, if you will. We'll get real fancy. All of these things have an origin. Still starts the origin. Our vertex for every angle that we draw will lie at the origin. Each side will always start in the same position. Each angle starts on the x-axis. That's our 0 line. Okay? Angles that are positive rotate upward. They go counterclockwise. Negative angles, you think, then go counterclockwise. They go the other way. Couple things that they define as. They will say that you have a theta in standard position that means that there's some angle has the vertex at the origin and what's called a terminal side. It's where the angle stops. And this is where it comes into play about knowing degree measurements or knowing how the quadrants are broken down. If this is 0, this would be, then what? Then what? And then?
360.
Very good. So what we do is we say, can you draw an angle in standard position at 225 degrees? So you have to figure out the quadrants. 1, 2, 3, and 4. So we'll draw angles in standard position that lie, and we'll ask what quadrant do they lie in, whether they're positive or negative. We'll find out about what are called coterminal angles. We'll talk about things like that as well. So let me show you an example of drawing an angle. 225. What quadrant will 225 degrees lie in? 3. Good. So that means when you draw that, draw your XY start, 0 line. Now that gets you to 180. 225 is how much more than 180? 45, which means it should come out to be about halfway. And I would label it as 225 cube 3. And that's what it is. Draw an angle in standard position, in what quadrant does it lie in? You're just spinning it to its placement. Bless you. Notice how I stopped for a second and said how far off of 180 does it drop? It was 45 degrees off of 180. We always check to see how far things are off of x-axis. Yes, sir?
Never mind.
Okay. Q3, quadrant 3.
We just do Q, we have to use the Q.
Why can't you use Q in a Roman numeral 3?
I'm just wondering, I can go on someone will do that I protest not all going to happen.
Congratulations, that's what you're going to state, right?
Yeah. Well, I got my going.
How about you going?
No, I mean.
Well, screw you then. Sorry. No, wrong email string. But no, still, it's awesome. You guys
You wanted to watch that.
Anyway, I'm harassing you because you're whining about writing down 3 letters.
No, but I mean, like, as if, like, that's always 3 letters.
That's 4.
Well, she's going to put a 3.
Eventually, 6.
You guys can play a lot.
7. So 7.
Yeah, that's 7 miles.
Math is hard. Same deal. You can play. Negative 300 degrees. Same deal. The only thing that changes is that I'm going to go the other direction. Negative 300 degrees still starts at 0 and just spins the other way. How far off is 300 degrees from that x-axis then as it's spun around?
30.
Is that going to be 30 or is that going to be 60?
30 from the 90.
We always check off of the x-axis. So this should be 60 degrees up if that's negative 300. And that's exactly what we're getting to. That's exactly what we're getting into. All of our our angles that we worry about in algebra 2 are going to be brought off of your 30, 60, 90s. Because what happens is, as we start to draw these things in, there's only 3 angles that you have to worry about. 30, 60, and a 90. Okay? If this is at 30 degrees, that has some specific value. Think about your 30, 60, 90 special right triangle. What was opposite to 30? So it was 1, root 3, and 2, correct?
Yeah.
Okay. So if I want to talk about in terms of bringing this back down to my x-axis, my opposite, my adjacent, what's the cosine of 30 degrees? Root 3 over 2. Yes, sir.
Would we have to worry about any other special, like, would we have to worry about 45, 45?
Yes, sir. Okay, are we okay on that? What is the sine of 30? 1/2. Now, this is some value x, this is some value y. You guys okay with that?
Yeah.
Now, if this moves over here to still be 30 degrees up from the x-axis, that gives me an angle of 150. You okay with that?
Yeah.
That angle still has what we call, and we're going to talk about this more in the next few days, a reference angle of 30 degrees. It's 30 degrees off of the axis. So it's still 1, 2, and a root 3. But what changes? Negative x.
Yeah, I was just about to say, wouldn't that root 3 negative?
Correct. So now you have the negative root 3 over 2, and it's still at 1/2. You bring it down 30 degrees past 180. What is that angle then?
210.
210. It's 230. So if I bring this through, this is still in the same vertical. This is still 1, but now it's negative. So the 30 degree here would have a opposite over hypotenuse. You're going to get negative 1/2. Oh, excuse me, I'm looking at I need the cosine first. Excuse me, negative root 3 over 2. My sine opposite over hypotenuse, because it just flipped. And then it comes back again over here. It's still the same value off of the x-axis. Yeah, well, squint. Okay. This is the whole basics here. If you guys understand how this comes around, how these values are created, everything else just falls into place. And it's just a matter of knowing those triangles. Yes, sir.
Who decided to make this?
That's just how it works, because it's just ordered pairs. It's just ordered pairs. Ordered pairs reflected over an axis at the same
I'm
reference
just
point.
curious though, like how somebody was just like doing something on a graph and they're like, oh look, this circle does this.
Yes, sir.
Instead of starting off like a 30, do like a 60.
Does the same thing. Does the same thing. And that's how you get your reference points, because there's only 3 different angles that are thrown in here. 30 mirrors, 45 mirrors, 60 mirrors, And then you have what are called your quadrangles, the ones that are on the axis themselves. Think about how we generated this. It was x root 3, and 2x, because this came from the special right triangle pattern from geometry. That's what it was. This is what we call, and I'm a few days ahead of where you guys are right now. So don't overthink about it. This is just some coordinate for this point in space. If I put this point here, this ordered pair at 1 and 3, if I move this over here to be at -1 and 3, because this line is parallel to this line. That's all I'm doing. And if I bring it down this way, it's parallel, it's just vertical, so that doesn't change. The other one changes. That's all I'm doing. I'm just doing reflections.
How did you get over to?
Opposite over hypotenuse.
Do you not suggest
No. Don't worry about this now. I'm showing where we're getting to. You're worrying about it. Don't worry about it. Okay? Yeah.
why is on the third quadrant, why is that side negative 1? Isn't that just
Bless you.
one?
Isn't third quadrant x is negative, y is negative?
That's the Bible? I
Yeah.
thought it was just the length side.
It's not length, it's placement. Because even though you're placed in space, when you square it, you don't get a positive value.
So when it's like on the bottom part of the y-axis, it's negative. Alright.
So back to this, okay? Back to this. The whole idea of understanding what these are and how things spin around, bless you, is so that we can eventually get to putting things into this, okay? So what we look at then are things that are called coterminal. Coterminal angles are angles that share the same terminal side.
Right.
So if I want to think of it in terms of what is called coterminality, things that are just coterminal, if I want to place an angle, find a positive and negative coterminal to, let's make it real easy, 45 degrees. When I place 45 degrees, what quadrant does it go into? First quadrant. So here's my 45 degrees, there's my terminal side. So stand up,
Okay.
and if you're going to face 45 degrees, let's just make it easy. Wouldn't we just look at that corner? So let's start this. I'll start at 0, facing north. Go 45 degrees, and you're going to be looking at the corner, right?
Right.
Okay. What do you have to do degree-wise as you're spinning around to face the corner again? 360. What's 360 plus 45?
405.
And I'm back at that same angle, aren't I?
Right.
Okay. Go the other direction. I went negative off of that. I backed out 360 degrees. So that's how you get positive, negative. You add 360 to it. You get 405. You subtract 360 from it. So you come back this way, and you get, what is that? Bless you, negative 315.
So you can get an angle over 360 degrees.
Yes, sir. And there's a trick when it happens when you have angles that are, because you can spin around all day long. You might fall over, but you can do it. Okay. What happens is positive and negative coterminal angles are going to allow you to spin back and forth to figure out what quadrant something lies within. It's going to allow you to find what's called a reference angle. It's going to allow you to understand what angle do I work with if it's 305 degrees and I have to figure out where did it spin to find out how far off of something I'm at. You learn how to spin things back and forth within one revolution. When I say that, you're spinning it within 360 degrees. Okay. Now, if I start, like he was asking, if I start over 360, for example, if I start at 900 degrees, that's definitely more than 360. Okay?
You don't say.
Yeah. Last time I checked, that's 360, 720, 900. Okay? That's 900 degrees. Okay?
Oh.
I continued spinning and I wound up here.
Are we supposed to?
What's that?
Are we supposed to go on this?
I'm showing you how this works to get the positive and negative. What happens is, when you're over 360 degrees, to find a positive and a negative coterminal, you back out 360 degrees until you're within one revolution. So am I over or under 360?
Over.
Back it out again. Am I within it?
Yes.
There's my positive coterminal. And then it's subtracted again and you get.
Negative.
So here's your positive, here's your negative. So if you were over 360, positive, you just subtract it until you're within one revolution. There's your positive. Subtract it one more time, there's your negative. Same deal goes if you're over 360 negative, you add 360 until you get one positive within a revolution, and then you add it one more time. Or within the one revolution of negative. Okay? Yes, ma'am.
So do we draw like a bunch of circles around it, or do we just go to one each?
Well, if you're trying to figure out where 900 degrees is, that's what I'm doing. I'm starting at here. I know it's 360. I know it's 720, and I go 180. I'm at 90 or 900. Excuse me. So this is the angle itself in standard position at 900 degrees.
And then how do we write like 180 and then get over?
Just like I did.
Just like that. You don't
Yeah.
have to do the graph.
No. Because eventually you're going to figure out where things are going to bounce. Okay? Yes, ma'am.
So, the positive and negative coterminals of 900 would be 180 and negative 180?
Yep.
Is that what?
Yep. That's it. Now, the other thing that we're going to start with tomorrow then is to switch this thing into what are called radian measure. Radian is in terms of pi. So go back to your starting point. We have 0, 90, 180, 270, and 360. One revolution is what we call 2 pi. So if you go halfway, it would be 180, which would be pi. Hi, how are you?
Pi is
What would 90 be?
object we cut off the spot.
Half pi. What would 270 be? 3 pi over 2. So the idea here is going from degree to radian. All you do is you take your degree value, divide it by 180, and slap a pi next to it.
Whoa.
Yes, sir.
Is that given that the radius of 1?
Yes, we'll get to that. Yeah. We're doing a little bit of it now because I'm going to have you convert a few of these. Yeah. We'll spend more and more on it tomorrow. And then to go the other direction, you just do the inverse. Radian to degree. You take your radian, you divide it by pi, and you multiply it by 180. The reason why I wanted to show you that with that 900 is that if you take 900 and you divide it by 180, or excuse me, not 180. Yeah, divide it by 180. The zeros drop, and you get 45 over 9, which is 5. Slap a pi next to it, and all you have to do is count. 1 little, 2 little, 3 little pies, 4 little, 5. It's quicker to count within radian as you're spinning things around. Works. It's part of it. Okay. What I want you guys to do tonight, yeah. It's still 13. This is 13. What do you call it? 52. The problems themselves, there's a mixture of radians and degrees. So let's see, this is on page 780. 28 to 51, only the degree problems. If there's a pi in it, don't do it. Now there's a couple of them on here that you're going to convert. You'll convert 25 degrees to radians. You'll convert 110 degrees to radians. So you're going to take it 25 divided by 180 and slap a pi next to it. Try to do this. Try to simplify the fractions without your calculator. Yes, sir.
Okay. All right. So we're converting radian to degree in opposite. Correct?
Today we're going degree to radians.
Okay, so
Radians degrees a little bit. It's the same idea.
So what exactly is like a degree and degree? Can you explain the difference? Or should I just?
The degree is more American style. Radian is the world, kind of like a metric system idea. Radian measure is a little bit more standardized. One full revolution is 2 pi. 180 is half of it. Pi over 2. It breaks it into easier fractions to work with.
All right, so just use degrees instead of pi.
Yeah, we use degrees more mainly. We teach things in degrees, and then we start the radian here.
Radians like a whole
World.
Oh, radians.
So,
We have the negative and positive terms.
I'm sorry, what's that?
With the negative and positive angle measure, or the degree term, whatever it was.
Yeah.
I don't understand. I mean, I can
Spin
get
it,
that,
yeah.
but I don't get what that is doing. What's that talking?
What'll happen is you start to worry about what's called a reference angle. It's off of where you spin things around. If you know how to find 700, 360, that'd be 720 if I go all the way up. So I'm 20 degrees off of it. So it tells me that I know that I'm 20 degrees away. It's allowing you to
Sort of, if you got the negative one.
yeah. It allows you to learn. It's
The starting at 700.
you can spin it. But remember, you're always bouncing off X. It's how far you are from X, never Y.
No, but I'm now.
Yes. Get the biggest edge first. I can probably do all the calculations first because if you get because you wind up with negative something.
No, it's a
Yeah.
joke. Oh, thank you. I was referencing his HGA.
Okay. And you did the math. You probably didn't divide by the negative because you know how it's minus 2AB cosine something.
Yeah, it's negative 2AB cosine. But one time it was like a squared plus b squared. You're trying to find c squared. A squared plus b squared is 41, and then the minus 2ab equals 40. So that
Okay.
equals 1. So you divide by 1.
No, knucklehead. This is times. You can't do. If this is 41 minus 40 cosine of some angle, you
Yeah.
can't do 1 because this is times something. Can you take 3 minus 2x and say it's x?
No.
You can't do the same thing here.
Oh, okay.
Because it's you're multiplying it times the cosine. Cosine of x, the cosine of that angle is just some crummy decimal.
So wait, so what would you do there?
You have to move the 41 to the other side, divide by negative 40, and then hit your inverse.
Okay.
Does that make sense?
Yes, thank you.
Common mistake.